Slope of a line. In this section, we have 5 objectives. We want to find the slope of a line given 2 points on the line. We want to find the slope given an equation. We want to be able to interpret slope-intercept form from a scenario. And then we're going to practice finding our slopes with our special cases of horizontal and vertical lines. And then last, compare the slopes of parallel and perpendicular lines. So for objective 1, we want to find the slope of a line given any 2 ordered pairs on a line. So the first thing we need to define is the formula. So the slope variable is the letter m, and I put it in italics here just so you can see it. It is the variable m, and it's coming from 2 ordered pairs. So we're going to call them x1, y1. The little ones that are written in subscripts are just to let us know that it came from the first ordered pair. Those 2 went together. And then the second ordered pair is x2, y2. So to find the slope of any 2 points, we want to be able to find out how much from one point to the other do we need to rise, meaning go up or down, and then how far do we need to run, meaning to the left or the right, how far do we need to go. So keep this visual in your mind that the number on top is telling us how far up or down to go. And so whether it's positive, we go up, negative, we go down. The bottom number is then always going to tell us to go to the right. So if you have your slope as a fraction, you can then graph it from one point to the next and follow it through the line. Now, before I get ahead of myself, let's write out the formula here. That rise is the difference in our y values. Y value is how far up or down we go, over the difference in our x values, how far left and right. And just to make sure you see it, notice that our subscripts of 2 are on top of each other, and our subscripts with the 1 are on top of each other. This is our formula that we are going to be using. So this is something that you absolutely need to know. So let's try it here with example 1. Find the slope of the line through the given ordered pairs 0, 4 and 2, 7. Then we're going to graph the line. Now we are going to find the slope, but I'm going to go ahead and put these 2 dots on our graph, because in order to graph them, all we need is the ordered pairs. So we can see our line right here. And then we're going to find our slope and make sure that we can see the slope in our line. So I like to label my ordered pairs x1, y1, x2, y2. That way I don't lose track of which number goes into which spot. And the fastest way to memorize any new formula is to get in the habit of writing it with the variables in it prior to plugging into it. So every time you use it, if you write it, it starts to just kind of work its way into your memory. So on top, my y2 is the 7 minus my y1 is 4. And on bottom, my x2 is 2 minus my x1, which is 0. Subtract on top, subtract on bottom. Always check to see if you can reduce the fraction. And there it is. My slope is 3/2. Now, I just want to make sure you can see this. Slope is in this form again of rise over run. So 3 is on top, 2 is on bottom. So we should be going up 3 and to the right 2 from one point to the next. So if we start here at 0, 4, watch as we go. We go up 1, 2, 3. We rise 3. And then from there, we're going to go to the right 2. 1, 2. And there's our new point. You should be able to follow the slope, that pattern, all the way through your line. And the only other thing I want to note for right now, because we'll come back to it, is this is what we call a positive line. This is going uphill in this positive direction. So it's positive. We can say it's uphill. We always read our lines from like left to right. So this is going upwards. And we will notice later that when you have a positive slope, it will be going upwards on your graph. Let's try example 2. We have the two ordered pairs, -4, 3. So that's x1, y1. And we have 2, it's over here, y. So that's our x2, y2. And then we want to graph the line. So again, I'm going to graph it first just so we can kind of see what we're working with. All right, and then let's find our slope. So let's write our formula, y2 minus y1 over x2 minus x1. My y2 is a 1 minus my y1, which is 3. On bottom, I have x2, which is 2, minus my x1, which is -4. And then we can subtract. On top, 1 minus 3 is -2. On bottom, notice we have a minus and a negative side by side. That's going to switch out for a plus sign. So on bottom, we really have 2 plus 4, which gives us 6. Because with slope, we're going to be having some fractions in here. I notice that this can be simplified by dividing both the top and bottom by the same number. So I could divide a 2 from both of these, and this simplifies to -1/3. So that means for our rise, we're going to go down 1 because it's negative. And for our run, we're going to go to the right 3. Let's see if that happens. So from our first point on the left, we are going to go down 1, right 3. We're not quite to the second point, so let's try it again. From where we left off, down 1, right 3. There we go. That's our pattern. And we can even fill in that dot there in the middle. That would have been another point along our pattern here. Objective 2, finding slope given an equation. So something to note here is that we have a format for writing our equations. From the very beginning of this unit, we talked about standard form. And standard form looks like this. It is ax plus by equals c. This is standard form. Now we want to talk about a new form. So it is taking that same standard form, our equation, however it is given to us. And all we want to do is rearrange it. I'm going to put it in parentheses here. We are solving for the y variable, meaning you want to get y completely by itself. And then what happens then is on the other side is you are left with this form, mx plus b. B we looked at in the last section is your y-intercept value. You can see it right there. And what we're figuring out with this section is that you can see the m. M is your slope. So your slope number, positive or negative, fraction or a whole number, is going to be attached to that x variable in this format. So that's how you can tell which one's the slope and which one's our y-intercept. So again, that slope is that rise over run value, and then that y-intercept is always in that form of 0, y. So that's what we want to be able to get to, is if we have things in this format, we can easily pull off slope and y-intercept from it. So let's try this here with example 3. We have 2 parts to it, and for both of these equations, we want to find both the slope and the y-intercept. But notice they're not quite the way we want them. So I'm just going to jot at the top again that y equals mx plus b, just as a reminder of like where we're going. We want to get y by itself. So on this first equation, we have -2x plus 3y equals 10. I want the y to be alone. So I'm going to put a little arrow above it just to remind myself, like, don't move it. And I want to move everything else to the other side. So I'm going to start by adding the 2x to the other side. You always want to add or subtract things before we do any dividing. So now I'm going to divide all of these terms by 3 to get y truly by itself. And that equals 2/3 x plus 10 over 3. And there we go. We've got both of our pieces here, the number piece connected to the x and the piece that's not connected to the variable. So let's define both of those. That 2/3 is our slope. Notice when I pull it off, I don't take the x with it. It's just the number there. So 2/3 is our slope, and that positive 10/3 is our y-intercept. So again, we write that as an ordered pair, 0, 10/3. Now let's try this one more time with our next one. Again, no matter how they give it to you, we want to rearrange it, y by itself. And this one's pretty close to having y by itself. It's just got a negative sign we need to move. So we're going to divide everything by that -1 to get that out of the way. So we are left with positive y equals -2x plus 1, because 2 negatives make a positive for us. And then we can again see we've got a slope, we have a y-intercept. So let's jot that down. That -2 piece is our slope. That 1 is our y-intercept as an ordered pair, 0, 1. Objective 3, interpreting our slope-intercept form. So this is where those word problems are going to kind of pop up for you, just to make sure that we can see what's happening within different scenarios. So this example 4 says the adult one-day pass price, y, for Disney World is given by the equation y equals 3.53x plus 67.39, where x is the number of years since 2006. Predict the ticket prices for 2026. So we can see there's a difference in years here that we want to change and see what happens over time. So the first thing we need to do is find this difference. So 2026 minus 2006 means that we have a number 20. That's the number we're actually going to be plugging in here. So we want to plug in 20, but then we got to make sure we're plugging it in the right spot. We have two different variables. Y is the price of our ticket, and X is the number of years. So X is where we want this one to go. We want this one to go where the X is, in there. So let's try it. Y equals 3.53 times 20 plus 67.39. So we are going to do order of operations. We're going to multiply first, get a response in your calculator. Then we're going to add in the 67.39, and we should end up with 137.99. And this is in money because we're talking about ticket prices, which is really quite crazy. But before I go beyond this, because we've found what they asked us for, I want to make sure we understand what we had here in our equation. So if I go back to this equation, this 67.39, this is your y-intercept piece. So this means this was the price in year 2006. That was like our starting point. So in 2006, they're saying the price for Disney was $67.39. This is where we started from for our graph. The other piece in here, this 3.53, this is our slope. And that means this is the change in price each year. Change in price each year. So according to this equation, from year to year, it only went up $3.53 each year. So slope is always the change per something, and then our y-intercept is always like our starting value. Objective 4, finding the slopes of both horizontal and vertical lines. For example 5, it says find the slope of the line y equals 3. Now we've talked about this before, that when you only have one variable, this is one of your two special cases, horizontal or vertical. And if we make a quick sketch, x is 3, that's where we are going to be cutting through our axis, which means this is actually a vertical line. Now, so far in this section, we've just given you the formula where you need two ordered pairs. So I'm going to pick two ordered pairs off this graph. We're going to use 3, 0, and let's also do 3, 1. So that spot immediately above it. Now I'm going to label them x1, y1, x2, y2. I want to use our formula, so let's get in a habit of writing it every time we use it. And then we're going to start plugging in the pieces. y2 minus y1 over x2 minus x1. We can subtract on top, we can subtract on bottom, and this is our red flag moment here, because we cannot have a 0 on the bottom of a fraction. If you try to type this into your calculator, 1 divided by 0, you'll notice your calculator gives you an error because this is called undefined. We cannot have zeros on the bottom of a fraction. And in fact, the problem with vertical lines is this happens every single time. Because we're not changing our x value from one point to another, we will always get that 0. So vertical lines always have a slope that is undefined every single time. Let's look at a horizontal line then. For example 6, we have find the slope of the line y equals 4. Again, if you think about where your graph is, we are crossing and cutting through where y equals 4. So this is a horizontal line. In order to use our slope formula, we need two ordered pairs. So we are going to use 0, 4, and let's do 1, 4. So the point right next to it. We can label them as x1, y1, x2, y2. Jot down your formula. The fastest way to memorize something is to use it. And then we can plug in y2 minus y1 over x2 minus x1. We can subtract. And then you might be thinking, okay, well, 0's not on the bottom here, so that's good, but 0's on top. So if we check it, type it in your calculator, 0 divided by 1, you get 0. And that's totally fine. We're good with that. And in fact, every time you are looking at horizontal lines, your slope is always 0. Because of the fact that it is not going uphill or downhill, slope is like another word for incline. So you can almost think of like a treadmill. So with that treadmill in mind, there are 4 scenarios. You have I'm walking on a treadmill. I just turned it on. I have my incline on my treadmill set to 0. And then once you start cranking up that incline on your treadmill, you'll notice your treadmill's getting steeper and steeper. It's going uphill. That's all the situations where your slope is bigger than 0. Or in other words, it is a positive slope. a positive result. Now, treadmills don't do great with negative slope, but just imagine if we had negatives in there, it would be like you going downhill. So that's all the situations where your slope is smaller than 0. So a negative slope value, you're going downhill. And just to just remind you, you are always moving left to right on these graphs. So that might help you visualize we are going uphill, we are going downhill. And the fourth scenario is that we are not Spider-Man. We cannot possibly walk straight up walls. So this would be like us over here falling off. So this last one is undefined. Horizontal or undefined. We cannot walk up a wall. All right, our last objective here, objective 5, we want to compare the slopes of both parallel and perpendicular lines. Before we can do that, we need to define them both. So think of something that's parallel lines. They are two lines going in the same direction with the equal amount of space between them. And my favorite example of parallel lines is literally in the word parallel. You have two parallel lines. Notice those two L's in the middle there. They are going off in the same direction. They have the same slope value with just different intercepts, different y-intercepts. But they have the exact same slope going off in any direction. So just to give you another little visual, that's parallel. But the big thing we want to keep in mind is this same slope. That's the big piece. If we're talking about perpendicular lines, that is two lines that not only cross each other, but they cross each other with a perfect 90-degree angle. So we like to call those opposite reciprocals because there's two things happening here. Opposite and having a reciprocal. Opposite meaning that they have opposite signs. So one of them has a plus sign in their slope, the other one has a negative sign. Reciprocal, that piece of it, means that because we are at this perfect 90 degree, one of them has a slope, we'll call it A over B. Reciprocal means B over A. So they are the complete inverse, top and bottom, of each other, and they have the opposite sign. You need both of those pieces for something to be considered perpendicular. And anytime you see a problem like this, we will typically ask you, are they parallel, are they perpendicular, or neither? There is that third situation. And most things would probably come up as a neither. But just be aware, we are looking for either the exact same slope, opposite reciprocal, and then everything else would be considered a neither. So let's try it here with example 7. It says, determine whether the line 6x plus 2y equals 9 is parallel, perpendicular, neither, to negative 3x minus y equals 3. So we have all three situations here. We have two equations. And the fastest way for us to find those slopes to compare them is let's get them all in that format of y equals mx plus b, because what we're looking for is that slope. Once we see it, we can decide what situation we have. So for our first one, 6x plus 2y equals 9, we want y to stay. So we're going to subtract 6x from both sides. We have 2y equals negative 6x plus 9. Then we can divide everything by 2 to get y by itself. Negative 3x plus 9 halves. Once y is alone, then we can find the slope. It's always attached to the x. Now let's do that for our other equation. We have negative 3x minus y equals 3. So I'm going to add 3x to both sides. Again, we don't want to move y, we just want to move everything else around it. Then we still have a negative in front of the y. So we're going to divide everything by -1. And we get y is negative 3x minus 3. And once we've got y by itself, we can find the slope. So looking between both of our slopes, we have a -3, and this one's a -3. They are the exact same in the same number, same sign, which means they are parallel. That's what we need for parallel. Same sign, same number. Example 8. We're going to try this again. Determine whether these two new equations are parallel, perpendicular, or neither. So first thing we need to do is solve them both for y. So I'm going to subtract x from both sides. Divide everything by 3 to get that y by itself. When you are dealing with the number and your x, always try to pull the number in front of the x. So don't leave it as x over 3. Make that a 1/3 with the x behind it. It just makes your life a little bit easier, because once we've got that y by itself, we want to be able to just see the slope by itself. Again, the x is not part of slope, it's just helping us find it. And then same on our other equation, we want to get y by itself. And then once we do, we can find our slope. So now let's look between them. This time we have a 3 and a -1/3. So let's see. They have different signs. So one of these is positive, one's negative. So they are opposite. Let's see if they are reciprocal. So one of them is a 1/3. So if you switch the top and the bottom, that would make it a 3/1, which matches. So that means this is a perpendicular situation, because we had both situations here. We had that it was opposite signs. So one's positive, one's negative. And then if you're looking just at the number, they are reciprocals of each other.